welcome to our second video in the 7-2 video series. We're going to continue working on graphing exponentials. In this video, we're going to take a look at how it affects your graph when your a value is going to be a value that is between 0 and 1. So this time we're asked to graph y equals 1/2 raised to the x power. Again, we're going to pick some different values, and I'm just going to plug in the same values that I started with on the other graph just to kind of give me a good starting view. Just going to use -2, -1, 0, 1, and 2. And so we are going to plug in these values into our equation. So we'll start out with -2. So y equals 1/2 raised to the -2 power. Now remember that to deal with a negative exponent, we flip it. So this actually will become 2 over 1 raised to the +2 power. So that's going to be y equals 4. So I'm going to fill in 4 there. I'll plug in -1 next. So we'll do y equals 1/2 raised to the -1 power. That's going to flip things, so we're going to get y is equal to 2. We'll plug in 0 next. Y equals 1/2 raised to the 0 power. So that means anything to the 0 power is going to be 1. So we will have a value of 1 there. The next value we'll plug in is 1. So y equals 1/2 raised to the first power, which is going to give us 1/2, or 0.5. And then we'll finally plug in 2. So y equals 1/2 raised to the second power. Remember, with a fraction, you square both the top and the bottom. 1 squared is 1, 2 squared is 4, so we get 1/4, or 0.25. So what I'm going to do next is to go ahead and plot these points on my graph. So I had -2, 4, so I put a point right there. I have -1, 2. I have 0, 1. I have 1.5, and then I have 1.5, and then 2 and 1/4. So that's going to be close to that x-axis, but not quite there. Now we'll go ahead and connect those dots. We'll make our curve, and we're going to level off. All right. Then the last thing we want to do is draw our asymptote line. Again, we look at the number that was added on the end. We don't have a number added on to the end, so that is going to mean our asymptote is 0 again. So I'm going to draw in that asymptote line of y equals 0, which is also going to answer our first characteristic question. If we go ahead and continue looking through our characteristics, we can see that we aren't going to have an x-intercept again, because it is not going to cross that asymptote line of y equals 0. Our y-intercept is going to be 0, 1, because if we look at where it crossed the y-axis, it's going to be right there at 0, 1, and we also can pull that from our chart. Our domain, we do not have any restrictions on our exponential function, so our domain is going to be all real numbers. Our range is going to be based off our asymptote. Our asymptote is y equals 0, and we are looking for the values that are going to be above that asymptote. So we want y is greater than 0. Now, we're asked this time separately intervals of increasing and decreasing. That's a little bit different than the way we were asked last time. We were just asked of whether it was increasing or decreasing. This time we're going to have to give intervals for both. Now, we did talk about in Unit 3 that an exponential is going to be either always increasing or always decreasing. Remember, both of these are looking as we go from left to right. So as we trace our graph from left to right, we are going to see that we are going downhill and decreasing. That is going to have to do with the fact that our a value was going to be a fraction this time. It was a positive fraction between 0 and 1. That's one of the ways that this graph is a little bit different than the last one. Anyway, we are decreasing, so that means we are never going to be increasing, and we're always going to be decreasing. All right, looking at interval of positive and interval of negative again. Again, that is based off of our x-axis when we're above or below it. If we are above it, we are positive. If we're below it, we're negative. In this graph, we are going to be always above it, so that means we are always going to be positive and never going to be negative. Now, the next thing we're going to need to look at is our rate of change. Our rate of change this time is looking for the interval from -1 to 0, and this is where we're going to work it over here so that we have room. Remember that these are x values, so we want an ordered pair at -1 and an ordered pair at 0. Now, I plugged both -1 and 0 into my chart at the beginning. I found that my value at -1 was 2, so I'm going to put -1, 2. And I found my value at 0 was 1, so I'm going to put 0, 1. And these are my two ordered pairs that I'm now going to plug into my slope formula of y2 minus y1 over x2 minus x1. This was our slope formula. So I'm going to do 1 minus 2. Since I used this 1 first, I have to use this 0 first. So I'm going to do 0 minus a -1. 1 minus 2 is going to give me -1. 2 negatives is going to give me a positive, so that's 0 plus 1, which gives me 1. And a -1 over 1 is going to give me -1. So my rate of change is -1. Finally, on our end behavior, we're looking as x approaches -infinity. So as x moves to the left, we want to know what's happening to y. If we are looking at the graph and going from left to right, from right to left this time, since we're moving towards -infinity, we can see that if we were tracing this, our graph is going to go up forever towards y being positive infinity. Finally, on our last one, we want to know as x approaches positive infinity, so that means as we go the other way, as we move to the right, we want to look at our y value. This time our y value is approaching our asymptote, and we said at the beginning that our asymptote was going to be 0, so y is going to be approaching 0. Alright, that wraps up video 2. There are still no U-tries. We will pick up a U-try problem after video 3. So go ahead on, make sure that you've got all your notes down for this video, and we'll see you in video 3. See you then.